There we go. And then this way, you guys can look back on this later if you need to review some details. Okay. If there are no more burning questions that anyone had about AVSpec, I'm going to go ahead and start off with just a quick tour of AVSpec and the AAVSO spectroscopy resources. So last chance for questions before I do that. Okay, let me go ahead and set up my screen share. Here we go. All right, so this is AVSpec. It is the AVSO Spectroscopy database. It's one of our greatest up and coming resources. We're rapidly nearing 10,000 observations in the database. We accept submissions, and our acceptance criteria are relatively non-stringent compared to some of the other spectroscopy databases out there. Our goal is just to collect data on as many variable stars as possible. So you don't have to have necessarily done your instrument response correction or have shot a standard star for comparison or anything like that, although that of course is always very welcome as it improves the data. But if you have a shot of some seldom observed cataclysmic variable or something like that, which you haven't completely calibrated that way and you want to submit it, we will welcome it anyway. There's still lots that can be done without the instrument response correction. To submit your spectra, you just go right over here to the Submit tab. If you have already defined some equipment and locations in your AVSO account here, they will show up. If you haven't done that, you can do that with the link down here at the bottom. I won't say how long it took me to notice that link when I first started submitting to AVSpec. Clicking on that takes you to the sites page. And then submission process is really simple. You just select your file to upload, say that you accept the GDPR, hit submit. After you do that, it will go into a queue where as the current validator, it will show up for me to look at. It's doing a search right now. Let's just give it a minute to load. So it's going to pull up all of the currently unpublished spectra. There we go. See, you've got a lot of good ones coming in. There's one. And then what the validators do here at the AVSO is we just take a look and make sure that your spectrum looks generally correct, that the wavelength calibration is all right, that the spectrum of the star is at least vaguely what's expected for the listed star. So like this is P Cygni, so it's got a bunch of different emission profiles that's expected for P Cygni. If you had submitted this spectrum and it said that it was, oh, I don't know, Capella, then we would say, that doesn't look quite right for Capella. And we'd send you a note and say, did you possibly misspell the star name here? So that's the sort of stuff that we're looking at, is just general correctness. Here I see that Balmer line is at the right wavelength, 4,340 angstroms. So it should be at 4102. Indeed it is. So that's how we check the calibration, is just by zooming in, checking on that. And here on my cheat sheet, I see it should go down 8. So it should be at 3798-ish. Yes, it is. Okay, so this spectrum looks good to me. It gets accepted. That's how we do that.
And my understanding was first time we are asked to submit a standard star spectrum or something when we upload something the first time. Wasn't that in any of the?
Yes.
I thought I read that.
Yes, great point. I forgot to cover that part. Thank you for bringing it up. So that is indeed how our procedure works. Your very first spectrum that you submit should be one of a special list of stars, which is listed here under the help page. It will also be listed in a drop-down when you go to the submission page. So if you scroll down to here where it says standard stars, it has some information about why we require that you submit one of these standard star spectra. It's basically just because we don't want you to be shooting a target that does unexpected things for your very first spectrum, where we're judging the quality of the spectrum. If you shot a target that does unexpected things and the spectrum looks unexpected, we won't know whether that's because it's the star that's being weird or whether it's something wrong with the processing. So we request that you shoot one of these standard stars. They're all, well, most of them are quite bright, easy targets. Doesn't take very long to shoot a standard spectrum. You just go through the normal submission process with that standard spectrum. We'll see it within a few days, should be approved, and then you can start submitting as many spectra as you want of variable stars. So yes, that's where this list is.
And as you said already, we don't need to do the instrumental correction if we don't want to. How about continuum removal? Is this accepted to do it like, or should that not? I think I saw some with continuum removal in the database and some, but most of them don't have it around.
Yes, that's a very good question. So right now we are actually working on kind of improving the guidelines of AVSpec and adding some guidelines for things which have previously not been covered. Removal of the continuum is one of those things that is not currently covered. So in the future, we're going to discourage it. We don't want people to be normalizing their continuums and removing them. Right now, there is no guideline on that, but I would still say, because pretty soon we're going to be publishing those updated guidelines, I would say don't do the continuum removal process.
What is the logic behind? Because that continuum removal is basically a change of the spectrum and or whatever, or some.
Yes. So the logic behind that is that it's very easy to distort or erase features entirely when you're applying a normalization, because it's very difficult to determine what the true continuum is. So that's one reason, is that we don't want that loss of information to occur on an individual feature level scale. Another reason is that the continuum itself is information. Now, it's not necessarily perfect information, because some of these spectra are not instrument response corrected and some are. It's usually generally pretty easy to tell which is which. If we have the option, we would rather the continuum be left in, because that is some form of information about the star, is basically what that comes down to.
Okay.
And the new guidelines should come not just as a set of rules with no explanation, but I've actually been working on some fairly detailed explanations of the reasons why and why not behind the new guidelines. So when we publish it, that sort of reasoning will be published alongside them. Okay, so this is the AVSpec website. You've already seen most of it. It's quite simple. The forum is, of course, linked here. That will take you to the AAVSO Spectroscopy Observing Section forum, which is a great place to go if you're just starting out. I know that we have some members who kind of haunt this forum who are very talented spectroscopists and very happy to help beginners. And then there are some other resources which I think are linked from this page. Yes, here we go. So that we have the AVSO Guide to Getting Started in Spectroscopy, which is linked here from the AVSpec help page. This is a great guide, particularly if you are using a slit spectrograph. It doesn't touch a whole lot on the slitless grading procedure, but for slit spectrographs, this is a really in-depth manual that will just walk you through everything that you need to know in order to take high quality spectra with your spectrograph. So you can find that on the AVSpec help page. There's also a technical manual which has some information about specifically what sort of FITS file format and etc. that we're accepting at AVSpec. You probably won't actually need to look at that as an observer, but if you wind up running into issues with your submission due to a misformatted FITS file or something like that, this is a good place to go look to resolve those issues. And then there's the quick guide to getting started with submitting spectra to AVSpec, short and sweet. And yeah, that's a good quick reference. So this covers the AVSpec site. There's one other resource which I would like to show you all, and that is the spectroscopy observing section page. So this is kind of the AAVSO's Center for Spectroscopy. We have link outs to a lot of the different resources which I've just shown that are on the AVSpec page, but also some information on the field of stellar spectroscopy as a whole. There are a few quick tips about operations you can do on your spectra. And then perhaps the most valuable thing on this page, a list of spectroscopically interesting stars, which are we highly encourage people to observe these specific stars and submit them to AVSpec. We have a wide assortment of variables here, and each one of these lists in the description the resolution and the wavelength range, which are recommended in order to get scientifically useful results from these stars. So make sure that you take a look at that when you're deciding which stars to observe, as that will help make sure that your data comes out actually useful to professional astronomers. So yes, and the last thing I want to show you here on this spectroscopy observing section page is we do now have a page over here on the right under the resources for spectroscopy section, which is called spectroscopy videos. And this is a directory to all of our webinars and presentations we have hosted on the topic of spectroscopy in the past several years. And it's another great resource if you're just getting started with spectroscopy or want to learn a little more in depth about spectroscopic hardware or something like that. We have some great presentations linked on this page. So there you go. That's a tour of all of the AAVSO spectroscopic resources. Hopefully it was helpful. Now I'm going to go ahead and finish our informal presentation here and open up a question and answer session. So anyone have any questions?
Well, I'm a newbie and I only have 200 grading. So, but you showed me everything that I need to research this in depth. And so I'm not going to ask any stupid questions right now because I don't know enough to ask questions. Is there anything useful I can do with a 200 grading in a small scope or?
Sure.
Yes, absolutely. So with a star analyzer type grading on even a small telescope, your main advantage is going to be limiting magnitude. You can get quite a deep limiting magnitude relative to those who are using slit spectrographs because the efficiency is just so much higher with a low dispersion slitless grading. One thing that I know that one of our most prolific observers for AVSpec is doing is a survey of fairly faint red stars. So carbon stars, S-type stars, M-type stars, those are often strongly variable and they all have extremely broad molecular spectral features, which are quite easy to detect with a star analyzer, even at low dispersion. The person in question who I'm thinking of is using his star analyzer in a filter wheel, which is very low dispersion. And you can get some useful data on those that shows those molecular features changing with time. With something like a Myra variable, if you track it with time, you'll be able to see the depths of the titanium oxide bands changing as the temperature changes. You might even see some emission lines appear at certain points in its variation. So yeah, there are some very interesting projects that you can take on with that.
Yeah, I played around a little with my star analyzer 100 2 weeks ago for a couple of nights, and I was also surprised, to be honest, how much you can see with that if you for a big distance between grading and sensor, I got up to resolutions nearly 400. Yeah? Which I thought is pretty good, yeah, for such a small tool.
Yeah,
of course, the light it gets darker, right? The bigger you make the distance between grading and sensor, of course, then the light gets stretched out over pixels, and you can only do less faint stars then, but then you get a good resolution.
And I'm going to watch the videos, but basically, what software is the standard for like a star analyzer 200? What do you guys use to reduce the data?
Over the last years, when mainly with slit spectroscopy, I was using BAS, BASS. I'm not sure whether you know that software. Is a public available free software, which is very, very powerful. I purchased AVSpec some time ago, which is of course much more convenient for the user, I would say. Right. Also, most of the functionalities are more or less, of course, identical. Having the standard functionalities that you need. I wouldn't say that I have a preference for one of the two in the moment. Maybe over time.
Yeah, those are exactly the two I was going to recommend myself. BAS is free. I found it to be quite difficult to use, but it has the advantage of, being free and very, very powerful. It has everything that you would need to do to a spectrum. It has a function for. AVSpec is definitely not free. It's kind of pricey, but it also does everything that you would need it to do for processing star analyzer spectra, and it's so very much easier to use. So it really comes down to how important do you feel it is to have a user-friendly software and tutorials and stuff like that.
But what I did not yet find in AVSpec, maybe, but because I didn't do it, but I know when 2 years ago or so, I looked at ALGOL and looking at the Doppler move, right, of the absorption lines, and then you need to do these heliocentric corrections and things like that. I'm not sure, is AVSpec able to do that? BAS is able to do that. I'm not sure about AVSpec, but that is, of course, then you need some high precision spectra to do that.
I think I have AVSpec. I bought it like 7 years ago and never used it, so I'm going to look into it. Can you put on the chat the name of the other, the AAS or whatever you said, so that I can look into it? Because I have the grading on a 61 millimeter piggyback scope to my 14-inch scope, which I do for exoplanet. I use for exoplanet, but I can change that grading and put it on the 14-incher now.
Well, that's a lot then.
Yeah.
Just BASS.
Okay, great, thanks.
Like bass guitar or something. But it takes some time to get used to it, indeed. Yeah, it's not as straightforward. But I mean, everybody likes something different, right? So. True.
And Matthias, you brought up heliocentric correction. I don't believe that AVSpec does have that capability. Now, I believe that the way we were heading with the new AVSpec guidelines was to actually recommend against applying heliocentric correction to spectra submitted to AVSpec specifically. So I wouldn't say that that doesn't rule out AVSpec for users who want to submit to AVSpec. But yeah, you're correct in that AVSpec doesn't have a way to do that I'm aware of.
No, I think it's only necessary if you have very high resolution and want to see exactly the velocity, the Doppler velocity, or calculate the Doppler speed and things like that, right?
Right.
So then.
Now I have a question.
Go ahead.
Hi, I'm David from Spain. Do you plan to extend the database to other objects like planetary nebula and such like that, or only just keep to variable stars?
We have no plans to extend the coverage of the database at this time. Right now, the determining factor for whether you can submit a spectrum to AVSpec is whether it has an AUID in VSX. So it has to be a variable star in order to get an AUID.
Okay.
So I do believe that there are other spectroscopic databases out there that accept amateur spectra of planetary nebula and such. I would look at the British Astronomical Association's database. And
Yeah, I know that one.
okay, great. Yeah.
Do you have a list of other databases? I know, of course, the British one and the French, the ARAS database, but other spectra database. If we want to look for something specific and don't find anything on,
Right.
on the AVSO database.
Those are probably the only two that I know of that take processed amateur spectra. I know that there's one SASDABA or something like that that accepts unprocessed star analyzer spectra. It's creating an image archive of star analyzer spectra. Let's see, I know an email I got recently that mentioned it, so I'll pull up the name and make sure that I got that right. But yes, I know of that one. I think it's mostly a Southern Hemisphere project. For some reason, I seem to recall that. I've tried using it before. I don't remember what star it was, but I had a star where I really needed some spectra. And I was unfortunately not able to find a spectrum in it, so I didn't really get to evaluate the database, but that's the only other one I know of. There's the BAA one, the Spectro ARAS one from the French amateurs, and this SASDABA star analyzer one. I'm going to just tab over here and take a look and make sure I have that name correct.
I'm going to look at the list. I'm going to try to get some spectra from STAR tonight and work with that and read through all of it and see if I can get something useful out of it.
Excellent. So let's see, you have not yet submitted a standard star spectrum to AVSpec. So that's the one you're talking about, right? Or is it? Let me rephrase that. Have you submitted a standard star spectrum to AVSpec yet?
You talking to me?
Yes, Pablo.
Yeah, I haven't submitted anything.
Okay. Okay. Great. Well, I'm glad that you're about to start submitting. Sorry, I know people by their observer codes, but I don't know your observer code, so I wasn't quite sure if you'd submitted yet.
I just came here to actually listen and ask a couple of questions, and you answer most of them because I'm going to go through that page that I didn't even know existed. I mainly do exoplanets now. I used to do variable stars, so I just contribute every night to the exoplanet database. I've had that grading for 7 or 8 years. Never used it. I just looked at it. It's fun, but since I have it now, I'm going to try to do a little studying and see if I can submit one. So,
great, wonderful. So I'll be quite happy to help you out with that. When you go to submit your standard star spectrum, that'll come into the queue for me to look at, and I'll give you feedback on that and let you know. So you saw where the standard star list is. Feel free to shoot one of those, and then any of the stars on the program priorities list on the spectroscopic section page, those would be good. And then honestly, when you're just starting out with a star analyzer on a scope like that, I would say just about anything you point at the sky, if you can see it, it's going to look interesting. So have fun.
I'm looking forward to that. Thank you. This has been very useful so far.
Yeah. Okay. Have we got any other questions about AVSpec? Okay. What about spectroscopy in general?
Can you get, I mean, do amateurs get radial velocity information out of the spectra? I mean, can you actually detect whether it's moving towards or away from us?
Yeah, if the resolution is high enough to see the Doppler shift, then you can do it. Yeah. So you need to calculate what the minimal velocity is you can see. If you look at the what is your basically your resolution then.
Mhm. Yep.
Depends a little. For example, if a nova, if you maybe make a nova where you have maybe the ejecta, which is coming in, has a speed of maybe 2,000 kilometers per second, right? That is probably pretty easy to detect with a lower resolution. Yeah, if you look at Algol or such a star where maybe the velocity is 100 kilometers per second or something, you need a pretty high resolution to see that. Yeah. So it comes to the how fast is it towards us or away from us, and how good is your resolution. Yeah. But it's easy to calculate. Yeah? If you know your resolution, you can easily convert it into kilometers per second that you are able to see, more or less.
Absolutely, everything that Matthias said. I'm going to put in here in the chat just a couple of handy formulas that I use whenever I'm trying to determine whether a certain velocity shift would be visible at my resolution, or if I'd need to find someone with higher resolution spectrograph. So just very simple, you can do that using the measure of redshift, the Z value. So that's especially useful when you're looking at say, okay, so here's an example. Just a couple days ago, there was a blazar up in Canis Venatici, hope I pronounced that right, which started flaring. It's at a redshift of just about exactly 1, so it's receding at about the speed of light. And it's normally around magnitude 18. It's currently flaring to magnitude 13. So actually, Pablo, I don't know if you have that kind of limiting magnitude with your star analyzer, but that is within the star analyzer regime. So if you'd like to give it a shot, it could be cool to detect the redshift of a blazar like that. And I was trying to figure out what sort of spectral features would be in the visible range. So I just applied these equations, very simple. The redshift, the Z number, is equal to the velocity over the speed of light. And then the redshift number can be determined observationally also by looking at the difference between the observed wavelength and the rest wavelength of a line, and then dividing that by the rest wavelength of the line. And with those two equations, you have all the information that you need in order to solve for what sort of resolution you need to detect the particular shift of a line, or where a line would be displaced to in the spectrum. 2 ways of phrasing the same question. So yeah,
that's pretty good. I guess what I'm going to have to do is remove the analyzer from the 61 millimeter piggyback scope and into the 14 incher now. So that has definitely going to improve my results. But yeah, look into it. Thank you.
yeah, that should give you a great limiting magnitude. Although I would say the blazar opportunity is tempting. Definitely give it a shot if that sounds interesting to you, but don't make it your first spectrum, because shooting something that faint is.
I'm gonna go to something magnitude 1.
Yeah, there you go. That's the right way to do it. Okay. Okay, any other questions about spectroscopy? Okay, in that case, I would like to bring up a kind of an interesting opportunity, which some of you guys might be interested in. So let me go ahead and start my screen share again. All right, so if you go here to the AAVSO homepage, and then go to Tools and Observer Resources, you can get to the page for AAVSO Net. That is our robotic telescope network. It is freely available to AAVSO members. We have quite a few telescopes all around the world. At any point in time, there's probably a telescope that's having some sort of technical issue, but that's fine because we've got 5 more that are up and running somewhere else, so we can always manage to get a particular target. You can submit a proposal using the proposal form here. There is a rather scary set of guidelines here on how to write an AAVSO net proposal. It's long, it's a bit strict.
Yeah.
It's also out of date, and the AAVSO net guys have asked me to rewrite it to be friendlier. So that's the new one's not up there yet, but just so you know, don't get scared off by that. Right now, they're taking pretty much any proposal as long as it's about a variable star. I mean, if you put in a proposal to observe M42 just for the heck of it, they're probably not going to approve that. But as long as what you want to observe is a variable star, just go ahead and submit it. Very simple. It's not nearly as official or bureaucratic as the term observatory proposal would imply. So just put in a few sentences about why you want to observe the target, add info about your target. You can do multiple targets if you want. And this is especially valuable because our telescopes, they all have full photometric filter sets, but also an increasing number of them are outfitted with spectroscopic capabilities. So right now we have a star analyzer equipped telescope running in the Southern Hemisphere. So if you have any Southern Hemisphere targets you want to check out, you can use the BSM Berry scope for that, and it has quite a short queue time right now. And there are quite a lot of cool targets for star analyzers in the Southern Hemisphere. That's where some of the brightest extreme O stars are. You can see some really weird emission in those. And then we also have one in the Northern Hemisphere with a star analyzer. There is a BSM Spectro rig, I believe is what they're calling it, which will be coming online. ETA not available, probably within the next year if you had to ask me, but don't quote me on that. And then finally, we have on a telescope in New Zealand. It's a 24-inch telescope, I believe. We do have a Shellyak E-shell spectrograph. Now that one is not quite yet functional. I'm helping some of the guys figure out software on that in order to control the acquisition properly. But once that is up and running, it should be fairly soon. That will afford AAVSO members the opportunity to shoot spectra of anything in the Southern Hemisphere at a resolution of about 10,000, covering the entire visible region. So it's a pretty great tool. And if it sounds like something that you're interested in, you can go ahead and put in a proposal now. And then once we get that software set up, which again should hopefully be pretty soon, your proposal will go through and you can get some data with that spectrograph.
I have an idea already. Right.
Right? Yeah.
BSM is the Bright Star Monitor Stations. Is that right? That's
Correct.
That's the list. Okay.
Yep, absolutely. There was a webinar not too far back about the upcoming BSM Spectro, or whatever it is that they're calling it. Let's see if I go back to the videos page. Oh, it's not on this one. It was in the, I believe it was in the larger BSM observing section webinar in 2021. So if you go to our YouTube channel, you can learn more about that upcoming system in the BSM observing section webinar. Gary Walker is the one who's putting that together. Okay, so I know that Pablo, you're working with a star analyzer and just getting started with it. Matthias, I know that you're quite experienced with using slit spectrographs, as well as some experience with the star analyzer. Correct me if I'm wrong on that.
Yeah.
Jim, I know you're just recently starting with a star analyzer. David, can you remind me, have you said yet what your involvement in spectroscopy is?
No, I just started out like 1 year ago, but I used to use the star analyzer 4 or 5 years ago, but then got a LISA spectroscope from Seljak, and I started out maybe 1 year and a half, and I uploaded quite a lot of spectra to the database. I'm not focusing on a particular field of spectroscopy. I'm just trying to find what field I like. Maybe planetary nebula, I don't know. I just pick up a little bit of everything, many different targets every night. So I'm not focusing yet.
That's an enjoyable stage to be in.
Yeah, well, sometimes it's a bit stressful to decide, okay, what will I observe tonight? I would like to have more guidance from professionals, as in photometry, the same. So that sometimes I feel like I'm wasting time, telescope time, not to do what they really need. But well, I don't have that backup.
Yeah. Well, it sounds like you're already knowledgeable about the RS group in France, but
yeah,
they would be the ones that I would go and talk to about getting connected.
Yeah, but sometimes with that group, I feel like I have very low profile for them. But I'm working out. There are very high standards in that group.
That's true. Yeah. That's sort of the vision that I see for AVSpec and the AAVSO's involvement in spectroscopy is being a bit of a bridge there, because there are these fantastic resources out there and these very impressive amateurs doing a lot of work in the groups in France and the Spectral ARS database and all of that. But you're right that their standards are so high that if you're a beginner starting out here, you can't quite jump that high to start with. So that's where I see my involvement, and AVSpec's involvement is in trying to help bridge that gap and help people get started out.
Yeah, great.
All right, well, I'm glad that you came to today's meeting. Thank you.
Yep.
And then I see that Kim said in the chat that she has a star analyzer 200 and will be trying drift scanning with an 8-inch Dob and 80mm refractor. That's great. You might know this already, but star analyzer 200 and an 8-inch Dob is basically what I started out doing spectroscopy with. It's a great setup. So good luck with that. And let me know if you have any questions or difficulties that you run into along the way, and I'll be happy to help.
Thanks, Lauren. Exactly. I mean, I watched your videos on your website as well as on the AVSO how-to hours on how you actually did the drift scan method. So there you go. You've got me into this.
Oh, that's great. I'm glad to hear it. It's a lot of fun. There's so much to explore out there. You know, we learn about the world of variable stars through photometry, and there's a lot of information there, but it's like the phrase that the quip that they say, if a picture is worth 1,000 words, then a spectrum is worth 1,000 pictures. I really found that to be true. Kim, this time of year, one target that you might enjoy shooting once you shoot some bright stars to get the hang of it, P Cygni is an excellent target for drift scanning with a star analyzer. It's got a lot of very bright emission, which honestly I found to be quite helpful with focusing. So some nights I would just focus on it, even if I wasn't necessarily shooting a science spectrum of it. And it's very dramatic. So if you get down to magnitude limit 5 or so before Cygnus is gone for the year, give that one a shot.
Okay, that's great. Thanks. I know I've actually used the star analyzer with our DSLR on Vega, and
Oh,
on
great.
Speak-Up. So I've actually taken a few spectra, but haven't quite got to the point of matching them up into AVSpec yet. So still learning that as well.
Yeah, there's so much to learn when you're just starting out. It's good to hear that you have AVSpec. So you may already have talked to him, but Tom Field, the creator of AVSpec, is another great person to talk to when you're just starting out. I've never met anyone who gives better support for their software. He's happy to help people not just with the software, but also with getting connected to experts in spectroscopy and helping them learn how to do spectroscopy and that sort of thing. And he's very responsive. So yeah.
Okay, thanks.
There are a lot of resources out there. It's just sometimes it's difficult to know where to look. That's where I was when I started out. I had not yet encountered the AAVSO, or even I hadn't even heard much of the French group doing things. Basically, all I had was Tom Field's website. That's all I knew about amateur involvement in spectroscopy, and it can be hard to get started. That's why I'm trying to show a lot of the different resources that are out there to give you all a starting place, places to look. All right. There's one more thing, since we do have a bunch of relative beginners here in attendance. I'd like to go ahead and share something, but it's going to take me a second to get the link. I've been creating just a few educational materials for AVSpec as part of the improvements that we're putting together. And this one should be going up on the AAVSO website in the next day or two, but it's not uploaded quite yet. So I'll just send you guys a generic link. Here we go. So this is a quick calibration cheat sheet. I'll share my screen for those of you who can't look at the link quite yet. That just covers some of the most useful wavelength reference points in a stellar spectrum. This is useful for moderately low resolution, like the resolution of a LISA or a star analyzer. You wouldn't want to use it for a very high resolution spectrograph, but when you're just starting out, these wavelengths are plenty accurate. And it's got some basic tips on there for when you're composing your calibration. You might see the options of using a linear or a non-linear calibration in AVSpec. This has some tips for when you should use linear and when you should use non-linear. And if you do use non-linear, it emphasizes that you don't want to use a fourth order or above non-linear calibration, because those are basically never necessary. I do see a fair amount of spectra come through AVSpec which have been overfitted in their calibration. So what happens, I think, is that observers, you type in your wavelengths, right? And then oftentimes the software will give you a root mean squares or RMS error number for how good is the fit to the wavelength, the wavelengths that you've put in. How close are the lines to the wavelengths that they should be? And oftentimes people think, okay, the smaller that number, the higher quality of the spectrum. That's true up till a point, but if you have to increase the nonlinear order of your calibration past third order or so, what's probably happening is that the tiny differences that are just natural due to noise and stuff like that, in your attempt to squash those, you might be making the calibration stretch or squash areas of the spectrum where you don't have any lines tracking the accuracy. And that's what we call overfitting the calibration. So as a rule of thumb, I would say don't ever touch those higher order polynomial calibrations. I know that BAS software gives you the option of, at least my version gives you the option of doing nonlinear calibrations up to some ridiculous figure like 27th order or something like that. It's not necessary. Okay. Did we have any more questions about AVSpec or spectroscopy in general? All right. If there are no more questions, then I think we should go ahead and wrap things up here. I want to thank everyone for coming today. This has been a great meeting. I hope that it was able to help some of you and give you a kind of a guide for getting started in spectroscopy. And I hope that I will be seeing your spectra in AVSpec very soon. I'll keep an eye on that standard star spectrum queue. Get you guys approved quickly. All right. Now our next AVSpec open house meeting is going to be on the third Thursday of the month, which is, let me check what date that is. That'll be the 21st, so July 21st. And right now on the forum thread, I believe it says that the time of day will be 9 p.m. It's actually going to be 1 p.m. I'll be updating the forum thread very shortly. We tried the 9 p.m. meeting thing and found that that didn't work for very many people at all. So they're all going to be at 1 p.m. now. I'm not trying to accommodate different time zones anymore. It seems like 1 p.m. works well, 1 p.m. Eastern time. So 21st at 1 p.m. Eastern time. Feel free to use the same login information if you would like to join that meeting. It won't ever expire.
Thank you.
All right. Thanks, everyone. See
Thank
you
you.
next time.
Thank you.
Thank you, Lauren. Great job as usual.
Oh, thanks. Bye.
Bye.
Bye bye.